So, does anybody have any questions for us? I for you to pick the after. We are in chapter 10 looking at price discrimination. And I passed out, did everybody get one of those? These the extras. Okay. So this is a figure from your book. What's that? Oh, Adam? Get one. So this is just a figure from your book. That walks you through the various possibilities of pricing strategies. So the whole chapter is pricing strategies. And in principles class, market segmentation. Oh, if we had student discounts, for instance, we could with their student ID and different elasticity, we could charge them a little less and charge a little bit more to the non-students. That's a form of price discrimination, but there's other forms that we see all the time that we kind of mentioned when we brainstormed a little bit of this. So on the sheet, it starts off at the very top. And you kind of work through the process of, does the firm have market power? So what is having market power? We did this in learning curve stuff. If we say a firm has market power, what does that mean from an economic model standpoint?
They can choose the price.
They can choose the price. So they face a, what does their demand curve look like? Downward sloping. It's as simple as that. So they face a being a taker, they're a price maker. Question more competitive setup where the price equals the marginal revenue, and so the optimal decision then is to marginal revenue equals marginal cost, where price equals marginal cost. They're kind of powerless on that. So if the answer is yes, then they are potentially could be a price discriminator. They might have some potential to be a price discriminator. So we could drop down to the next pink box where you guys have black and white. But so what you might want to do is on the side, the reason I wanted to give you guys a hard copy of this is under perfect competition, you might draw a little model to yourself that looks like this. So this is the representative firm, and the demand curve decision looks something like this. We maximize profits by producing the quantity, revenue generated, blah, blah, blah. But hopefully that'll kind of trigger what's going on there for you. If the firm has market power, we drop down to the next box, and can the firm prevent resale arbitrage? So, if the answer is no, we're back to our monopoly setup. All right, so why is that important? Why do you need to, how does resale and arbitrage kind of wreck your diabolical plans as business to maximize profits, heaven forbid? If your product has the ability to be resold, what's the problem?
It's going to drag your price
Down, right? So you're kind of almost giving competitors the product because they can buy it from you and then resell it to somebody else, right? And kind of get that price break. So that needs to be done. If we can't, then we fall in a normal. It says production, but it's just the situation where there's a downward sloping demand curve. So yes, we have market power, we only charge one price. Quantity where the revenue generated by cost the last unit, we charge the highest to pay, and that is our monopoly and monopolistic competition for a single price monopolist, and that's the reason why. So if we can prevent resale and arbitrage, so maybe we're doing haircuts, a service or something, or something that can't easily be resold, does the firm's demand curves? We can't have customers, it doesn't work either. So if everybody's basically the same, then it doesn't work. We need to have some people have some different demand curves. So out of our customer base, if some people have a demand curve that looks like this and others have a demand curve that looks like this, now we're in business. Maybe this is the students and this is the non-students. Maybe this is the elderly and this is the youth. Maybe this is the whatever and this is the whatever, the high-income people, low-income people. However you're able to categorize them, you need to have different demand curves. Now, this is where we can still get into some fancy stuff. If there are people with different demand curves, even if people are identical to each other, we might be able to induce them into buying more from us. And this is where we'll talk, this will be the last topic we look at, but block pricing and two-part tariffs, so that we have an identical human being with a demand curve that looks like this. 10 units, they're willing to pay $, but there's still, that same human being is willing to buy more, but you just can't charge as much, right? So what if we offer a volume discount of some sort? So they're willing to buy 20 units, but only if the price falls. So then we're going to get into pricing schemes that might be able to induce those people to buy more. And that's kind of where this direction goes. So even if we don't have people with different demand curves and we're just talking about the average Joe. So, do the people have different demand curves? Yes. Can the firm identify the customer's demand before they buy the product? So highlight before. After is too late, typically. So if the answer is yes, I want to go directly to what we did in principles class. That is what's called third-degree price discrimination or market segmenting. This was the students, non-students. Pull out your student ID to prove that you are a student, and we charge different prices that way. So first-degree price discrimination is the one we left off with last time, perfect price discrimination. So we got first degree is like if you could perfectly do it, what would it look like? And then this is known as third degree price discrimination, being able to separate them out. Okay. If we can't separate out the people before, so if the answer is no to that question, now we can get into couponing, different versions, different kind of clever ways to get people to sort into their own versioning might be a software package that has all the bells and whistles on it versus the software package that is just kind of the basic version, right? So you got the basic version and you got the premium version, right? Well, everybody would love the premium if it was the same price. Those people who are not price sensitive would just jump on to the premium package, right? So if you're loaded and you're like, oh, I want Adobe Editor, what's the price? Oh, $900 for this one, $400, well, this one's better than this one. I don't really care about money, so I'll buy the premium one, right? So by setting up, and what was the cost to the company? That's actually more costly for them to probably restrict the package down to not allow all the bells and whistles, right? Because these people are engineers. They're like designing like the Cadillac version of, you know, the best that they could do. That's the premium package. sometimes they pull out pieces to water it down to a basic, just so they can participate in profit maximization. That's why they do it, right? They need to turn a buck in order to make their venture sustainable in the long run. All right, and then the last thing we can do that we see happen even at the fast food, can we package things together in such a way that we can sell more product by adding value through putting things together? All right, so I did a lot of talking there. Questions or comments? We're going to explore all these little avenues in different ways, working through some problems. All right, so we left off last time thinking about a formula that helps us price things in an optimal profit maximizing way. Okay, now this thing's a little bit dark. I think it's fine. Once it gets locked in, I don't know if I could really see the screen or not. So we had the learner index. So we left off with chapter, chapter 10, but 10 point, what was it, 10.2 or 10.1? 2. Okay, so go ahead and start calculating the part A of the problem. We kind of left off last time just laying it all out. We had the hair salon in 2 different locations, different elasticities, kind of going along this lines, right? We have different hair salons, different locations, different elasticities of demand. So let's treat them differently. So what are your salon's optimal markups and prices in each location? I'll rewrite the formula we did last time. So as soon as you get an answer, let me know what you got. What we're looking for is the price in each area. The price in Ohio, and the price in Pennsylvania. There you go. Yep, that's the one we left off. Okay, so you got it, right? You got an answer? What'd you get?
$45.
45. Oh, are you looking at your book? No book looking.
I did it to start it.
All right. No book looking. I want you to force those neurons to go, but that's all right. You can work with Max. You guys can talk. 45. That's right. You didn't get. So you've got the P over P is 1 and 30 over P. Right?
Yeah. I just did my math.
Yep. That's what comes to me up. Do the same thing. P is kind of a little bit tricky. How do you do it, Blake? So they give you the marginal cost. Oh, you're doing it over here? Okay. So you're solving for that P. So P minus 30 over P equals the 1/3, right? And then solve for P. And this is where it gets, this P over P is, it might be easiest to go 1 minus 30 over P. That's where it gets a little weird. No, I don't think it is. So P, okay, it's not P squared.
I don't know, what I did was I did. It's not P squared? And I top of the P and the other side of the P.
Well, try, just distribute that P through. So if you go, let's do it here. This is P minus 30 over P, which is equal to P over P minus 30 over P. P over P is 1. Run with it from there.
What'd you say to do after we get in here?
So you've got the, distribute the P through.
So
So
P
P
over
over
P.
P
Yeah.
minus 30 over P, right?
Okay.
Equals the 1/3. And so now the P over P is 1.
Right.
So that simplifies down to 1, and now you got 1 minus,
30 over P.
yeah, and then just solve it the rest of the way through.
Equals 1/3. Okay.
Got that?
This is, I like it to look at this part, because I didn't know how to get the P equals 3. Which is what you just asked about.
Okay. So are you comfortable with handling that?
Then P minus 3 over P.
Yeah.
That's what I mean, that's the part that I didn't get, because
Okay.
I didn't know how I got to that,
Okay.
which is what we just asked.
So I would go ahead and write that out, yeah, and then solve it the rest of the way through. Yeah, 60 for Pennsylvania. Let's see. Okay, so so the P over P. Okay, so you threw the P over to this side. Okay, that's fine, or you can do it that way. And then you brought the, so it's 1P over here, and then it's 2/3 P, and then 3 times 2, so then you're close, but you didn't get this right. 3 times 30 is 90, divided by 2 is 45. So I mean, this is all fine. So Blake took a little bit different approach, which is fine. If you threw the P over to the other side, you guys comfortable with that? Okay. Taylor, you good with it? Yeah. Okay. All right, so this is a convenient little maneuver to use elasticities and solve for prices. Again, it's not exactly how businesses would do markups typically. We talked about that last time. But what it is all of this is derived, and I'm not going to do the mathematical proof for you, but it's all derived from marginal revenue equals marginal cost. So the optimal condition that we've been using graphically and solving for in the last chapter, setting marginal revenue equal to marginal cost, that can all be proved to be equal to this formula. It's kind of cool if you get into that geeky, nerdy proof stuff like that. So, but you can start from there and work your way down. Otherwise, you just have to kind of memorize this formula, which is actually probably a little easier than going, and you can take it on faith that that's where it comes from. But it gives us in a nice little package what we've been doing graphically over here, which is solving for this price, just by having the elasticities with each one. All right, so what did we get? Ohio was that our 45? Or do I got them backwards?
Can you simplify in that one sentence here with
Yep.
1 minus 30 over p equals 130?
Is that Ohio?
Yeah.
Okay.
I can't.
Let me just do the whole thing here. So P minus 30 over P equals 1/3. And so this equals 1 minus 30 over P equals 1/3. 30 over P equals, and now we can bring this over to here. 1 minus 2/3 equals 2/3. P equals 45. Right? P, 3 times 30 is 90, divided by 2 is 45. Now, Blake did it a little bit differently, so again, that's why I kind of want you guys to do it on your own and figure out what works for you. Blake threw the P over here, so he ended up with P minus 30 equals 1/3 P. He threw the P over there, which is fine. And then we've got P, 1P minus 1/3 P is 2/3 P equals 30. How about that one, Max? Does that work better for you?
Yeah.
So if you throw the P over there, then you subtract the P's, and you get the same answer, 45.
30 over p equals 2/3. You multiply it p to get on both sides, correct?
Yeah, I kind of threw the P over here and got this over here.
Oh, you cross multiply?
Yeah, that's all
Yeah.
I did.
Okay, that's why it's not making sense. Okay.
I mean, there's steps of, you're multiplying each side by P. I multiply this side by P, and I multiply this side by P. So I'm just kind of doing those steps. I'm skipping some steps as I go, but okay. All right, anything else on that one? So then we got Pennsylvania was 60. All right, so what's the last one? Oh, why do they differ? We kind of talked about this last time. Okay, good. So less competition, more inelastic. That was the connection intuitively, kind of the economics in your belly that I want you to have, is that Pennsylvania had less competition, which means a more inelastic demand. So they had the 2, and that led them to having higher prices. Okay. Anything else on that problem? All right, 10.3. Next problem. Suppose you are a pricing analyst for Megadat Corporation, a firm that recently developed a new software program for data analysis. You have 2 types of clients who use your product. Type A's inverse demand is that, where Q represents users and P is the dollars per user. Type B's inverse demand curve is a little bit different. Assume that your firm faces a constant marginal cost of 20 per user to install and set up the software. If you can tell which type of buyer is buying the product before a purchase is made, what prices will you charge each type? So, let's talk through the thoughts here. If you can tell which type of buyer is buying the product before the purchase is made, what prices should you charge each type? So how are you going to approach this?
Change the demand curves to, since they gave you marginal cost, can you change the demand curves to marginal revenue?
To marginal revenue, right. So you want to determine Basically, determine what the marginal revenue is by manipulating the inverse demand curve, which is that twice the slope thing, right? So now you're gonna have a marginal revenue curve for each type, and then maximize profits for each type individually. Okay, good, good. So you're doing type A, or did you do type A and type B?
Yeah. This is type A.
You're good on the quantity, but
Don't you-
not the price. I know what you did. Think about where you shoved that quantity into.
I plug it in there.
Why?
That's the marginal cost. I need to plug it back into there.
Mhm. I think if I was you, and you guys are, some of you are smarter than me with math, by the way, believe it or not. I just know more math than you, but you're probably sharper than me with math. You might want to draw yourself a quick graph. You've got the inverse demand curve. For me, that always helped me visualize the problem a little bit better. Some of you may not need to do that. It's not required for the problem. But we've got the A type, we got the B type. I think this would have helped with Max's little whoopsie that he just did. Type A is at 120. So you got the demand. And you have a marginal revenue. And you got 60. And then we've got marginal cost at $20. So Max, what'd you get for a price for 70 after you, or for type A?
70.
After I gave you that little Freudian slip.
B, it's 40.
And B 40, that's correct. You get all both types? To the demand, yep, you got it. Knock out both. All right, so here's the picture that I drew, if it helps you at all. So we had 5 and 10. 5, these guys charge a price of 70. And optimal quantity here is 10, charge a price of 40. Not exactly drawn to scale, but that's the concept, right? So we're charging each group, we're kind of doing our own separate profit maximization process. Okay, part B. Suppose that instead you cannot tell which type of buyer the client is until after the purchase. Suggest a possible way to use quantity discounts to have buyers self-select into the pricing scheme for them. So, let's try to put on our gut feeling here again. We've got 2 different types of people, right?
We know the demand curve of the 2
Good point. So we know that we have two groups of people with different demand curves, and we know their demand curve. That's correct. So the only difference is we can't separate them out. We can't do the show me your student ID and I'll only charge you 40 concept. So how can we get the people in?
Well, could we, like they're saying, use some sort of discount to figure out their elasticity differences?
Okay.
The change in price and figure out.
Yeah, we want to think about each one individually. No, that's good. What else? Brainstorming. Some coupons, so some sort of discount that these people wouldn't use, that these people would. How much are these people going to buy if we just price them out at 70? Not going to buy any. What does the market demand curve look like? So what does the market demand curve look like? In other words, if we can't separate out these two groups, what does it actually look like? Because that's what we do if we had to fall back to a single price situation. So let's do that exercise. That's not asked here. It's kind of separate, but I kind of want to push you a little bit on the market demand. So the market demand is the sum of the individual demands. So what price is up here? This interception here, 60. So that was our, what did we call that with the inverse demand curve? The choke price, right? So that was the price at which these people started entering the market. So the market demand curve is going to look like at a price of 70 down to 60, it's going to look exactly like this one. I'm sorry, not 70. At a price of 120, it's going to be just these guys in the market, right? So it's going to go down until we hit that price of 60 where they will jump into the market. So if we go halfway, since 60 is halfway here, this ends up being kind of a point where it's going to become more elastic, and we're going to have more people jumping in. So at a price of 60, how many A people do we have? You have to calculate this. We don't have the answer. So at a price of 60, how many A people are we going to have? We know, by the way, that at 70, we've got 5. So how many do we have at 60? 6. Let's see, we got 120 minus 10Q is our demand curve, right? So 10 times, or we got the 70 over here. So, is that what you got? So if we solve for 10Q, if we solve for the demand curve, we got 120 minus P, or Q equals 120 minus P over 10. So this is 12 minus 1/10 of P, right?
Yeah.
If you're not seeing that, start writing it down. You can copy down what I got here. So P equals 60. What's that? Oh, well, yeah, so you just did it up here?
Well, I can do it out. If it was me, I would just do it from the 120 minus 2 over 10.
Oh, okay. Over there. Yeah. Yep, you can keep it that way. I'd say you're right. In this case, that makes it a little bit easier. I was going right to slope-intercept form, so we knew the 12. So answer is 6. Good. Okay. So now, once we jump into the market here, let's figure out what it is at 20. At a price of 20, what do we got? 10 for A, okay. So you got 10 here. And what do we got here? 20 for B. So we got 40 in the market. Something like that, right? And then we could be anywhere in between. It's going to be a line in between. Okay, and so now if we were maximizing profits, we'd have to figure out the marginal revenue associated with this line segment. So you'd have to figure out, now you would be forced to have to figure out what this ends up being. So it gets a little bit uglier. All right, but it's possible, right? So I'm going to stop there because we can do marginal revenue equals marginal cost, and we solve for something that's a blending of the two. So the question is, knowing that we've got two people that are different, can we do better than the blending? So how many will these guys buy if we start goofing around with prices? Let's start thinking about the A people. If I price it at 40, are the A people going to buy? What are they going to buy at a price of 40? Let's say I just price it at 40. We did the 70, right? 70, these guys are out of the market. Let's try the 40. What we're doing is we're kind of testing, like, how do these guys behave versus these guys? So what's going on if we charge 40 to everybody? Solve that one for these guys. How much? 8. So at a price of 40, not quite drawn to scale, of course, here, but we got an 8. All right, now we might be on to something. Look hard at these numbers. You guys can figure this out. What could I do to get these people to buy at 40 without alienating these guys? What must you do if you get the special price of 40? If we just price it at 40, we're going to sell 8 to these guys, and how many over here? 10. What do some places like Sam's Club kind of make you do? Have a membership is one part of it, and then what else do you end up doing when you go there? What type of stuff do you buy? Bulk. Think bulk. If we price it at 40, what's the quantity that we need to kind of have people buy? What's the minimum purchase needed? Eight's our break even, right? But what if we charge 10? What if we say that the minimum purchase is 10? Do these people buy 10? No, they don't want 10, right? So the most that they're willing to pay at a price of 40 is 8. So they're not going to buy into that deal. So over here, these people are going to buy all day long at 40. They're going to buy the 10 units. The regular price is $70. However, if you buy 10 units, you can get special pricing of 40. These people aren't going to take that deal. They're still going to buy at 70. because they're not willing to pay that much for 10, right? That's what the demand curve tells us. So now we've segmented the market before the fact without being able to identify the customers. Getting a little tricky, right? A little clever. What's that?
I don't think it makes that much sense.
Why?
Because the consumer get it. You're originally paying $350 to buy 5. That's the price of 7.
At a price of 70 here.
Yeah, you're paying $350 to get 5.
Okay, that's the spending for 5. Got it.
Or you can double your quantity for $50 extra.
Right.
And I just don't get that. The
So-
concept for a consumer to not buy into that.
So we got to take the problem as given that this is the demand. And in some cases, that's the case. So we can kind of play well, what is the right thing that would induce you? And maybe you're right again, this is just a problem. So theoretically, it's out there. And we could start to push it to extremes to make our belly feel better. But I totally agree with you. As a consumer looking at it,
No brainer.
you're going to spend $400 to get double at the price of, and I should say, not $350 for a quantity of 5, $400 for 10, and you're saying, well, that's no brainer. I'd get double. But if you have zero utility for those extra 5 units, should you spend that extra $50?
If it's a good that goes bad or not, if it's something that you save and use in the future,
Right.
then eventually you might have utility for that.
Yeah. So then
And
we can
what's
get into
the opportunity cost
storage
of
storage costs and yeah. So, but the stories that you're telling all involve the utility function that I'm claiming is embodied in this demand. So we've already taken that into account if you want to think of it that way. Again, it's a theoretical problem, but you can start to see the game that they play, and we know that this goes on, right? Now you know why. This is what it is. So if the consumer, if type A consumer gets zero utility from additional units, then it can be a pretty substantial price break. Especially if the marginal cost is zero. Let me give you an example from the high school football game. I was selling at the concession stand to raise money for the soccer team. And the popcorn, I don't know if this is going to be a good example or not, but I thought I was being my econ guy. So the popcorn runs $1, okay? Adam, you probably know this from high school, right? So who else is out of high? None of you, right? Okay, so so they got the popcorn machine, and the popcorn gets donated and the bags get donated. So the marginal cost to the club of popcorn is 0, right? So they ran out of the bags that they normally use, and they were having to use the smaller bags. And so the person who I was working with said, well, let's just make them 50 cents because it's 2 now instead of, because they're smaller bags of popcorn. Well, then when somebody comes up to the window, they say, I'll take a bag of popcorn, right? And they say, well, they're 50 cents because, they try to explain the whole thing. And they'll just say, oh, that's fine. They'll just take 1 bag. But instead, what I told them to do is just grab 2 bags of popcorn. Get the buck out of them, right? The volume. Get the volume out of them and give them 2 bags and say, hey, it's your lucky day. You get 2 for 1 today because the bags are kind of small. And they're like, oh, well, that's great. But if you give them a choice to either pay 50 cents or $1, then a lot of times they took the 50 cents. But we're just trying to make money for the club, so I want their $1 rather than I want their 50 cents, right? If you give them the choice, the additional utility that they got from the extra bag of popcorn wasn't very much. So don't give them that choice. Get the $1 from them. They were already told on the sign that said popcorn $1. Here they are coming up to the window, and they're more than willing to pay $1 for popcorn. Just give them 2 bags and take their $1. Right? Yeah, that could be too. But with the popcorn having 0 marginal cost, we don't really have any incentive to do that either. We'd rather have a happy customer leaving that'll come back for more popcorn later because they think it's the greatest deal of the day that they get lots of popcorn for $1. So that is kind of the volume concept and how we can think about people's preferences and behavior according to their demands to try to maximize profit or to maximize proceeds for our non-profit soccer team at the high school. So same type of thing goes on. All right, we're going to call it a day there.
So the multiple choice test on Sunday is over what chapter? 6?
6 through 9. 6 through 9.